All right, now let's pick up from the last video. We're working with the Poisson, and we're going to do an application here. It says a college switchboard gets an average of 3.5 crank calls per day. Use Excel to create a probability table and a graph for 0, 1, 2, and 3 such calls in a day. Does your result confirm the prior computation was correct? Remember, we did this in the last video, okay? And I think we got about 18.5% as the probability for 2 calls in a day. But we use this formula. Let's use Excel now. In the first column, we're going to put the possible number of successes, our X values. We could have 0, 1, 2, or 3 successes, because that's what it says here. And then we're going to use the Poisson function, Poisson.dist, to create those probabilities. Open up our argument box, and for the X values, we're going to select our first cell. For the mean, we're going to put in the mean, which it gives us at 3.5. And then we don't want cumulative for this particular distribution. Gives us the percent probability. Let's pull that down, and now you have a probability distribution. So this confirms our prior computation because we saw that the probability of 2 crank calls using the manual operations gave us 18.5%. Now we're doing it with Excel, and we confirm 2 is 18.5%. Now let's create that bar chart. We're going to click on our data, go up here to Insert, and make this a little bit bigger here so we can see it. And same process, we're going to select Column Chart. And what we want to do here is get rid of the bars that are not relevant. Looks like it's this series here. And then clean it up a little bit. We still run into the same issue we had with the binomial, where it populates starting at 1. So 1 here says 3%, but that's actually corresponding to 0. So we need to modify that. So we're going to select our data, and we're going to modify the horizontal axis and scroll over this data here. Click on that, and you'll see that it now does it correctly. 0, 3%, 1, 10.6%, so on and so forth. So we have our discrete probability distribution using the Poisson. Okay, let's continue on. Says the probability that a soccer player will be seriously injured in a game is 0.003. There are 150 players in a league. Using Excel, create a probability table and graph for 0, 1, and 2 serious injuries during the games on a given weekend. So again, we're just going to do the same process in Excel, just different numbers. And for this one, we need to use a 0, 1, and 2 success. I know it sounds weird to say serious injuries are a success, but you know what that means. 0, 1, and 2. Okay. And then we use the same function, Poisson. Okay. Pull up our arguments here. Our X values, possible successes, are in the first column. And then the mean. Now this one here doesn't give us the mean, right? But it does tell us that we have a 0.003 probability of being injured, and there's 150 players. Well, recall that the mean of a distribution is NP. So we can simply take 0.003 times 150 players in a league. Okay, let me go ahead and cancel this and do this right here. I'll calculate the mean. So we have 0.45. Now let's go back and do the Poisson now that we have the mean. Shut that off. I'm going to have to lock this because when I drag these down, it's going to change if I don't. And I'll change it to %. Okay, and again, let's round it 10th place and then drag it down. Okay, and there we go. So the probability of 0 injuries is 63.8%, 1 injury, 2 injuries, so forth. Now we can create a probability table. To do this, we follow the same procedures for creating a bar chart. Scroll over our data, go up here to Insert, Column, get rid of the ones that don't matter, and then we're going to clean it up a little bit. Starts at 1, we need to change that. Select Data, and edit the horizontal axis. And there we go. So 0 is 63.8, 1 is 28.7, so on and so forth. Okay, that's it for the application. Let's next move on to the hypergeometric distribution. This one would not be used very often in our social science research, but it provides a nice contrast to the binomial and the Poisson to fully understand the variety of discrete probability distributions available to us. I want you to notice the similarities and differences to the binomial. So it's the same as the binomial in that there's two outcomes, success or failure. It's the same as the binomial in that there's a fixed number n of identical trials. But it differs in that the probability is not stationary. It's not constant from trial to trial. And the trials themselves are not independent. It's very analogous to that lottery ball example I gave you in a previous lesson. If we use that lottery machine, when one ball comes out, the probability of the second ball coming out changes. And then when that second ball comes out, the probability of the third ball changes. Remember, 1 out of 100 for the first ball, 1 out of 99 for the second ball, 1 out of 98 for the third ball, so on and so forth. So we don't have stationary probability, and there's no independent trials, because if the first ball that comes out is a 12, then the second ball that comes out cannot be a 12. Right? It's already come out on the first one. So what happens on the first trial does influence the probability of subsequent trials. The conditions under which this would happen is we've taken a sample without replacement or from a small population. So we can avoid having to use the hypergeometric distribution by taking a sample with replacement or from a large population, which is what most researchers would do. That being said, let's now move on to an application. And we are going to focus our hypergeometric analysis on Excel, as opposed to doing the manual computations, simply because for our purposes, we would almost never need to use the hypergeometric. It's good for an introductory stats class, but it is not necessary for studying, researching social science type issues. But we do want to know how to use it in Excel, so we can contrast it from the binomial and Poisson, which are the more common distributions, discrete distributions. So here it says 3 different computers are checked from 10 in the department. 4 of the 10 computers have illegal software loaded. Using Excel, create a probability distribution table and graph to confirm your answer. Okay, so we're going to use Excel. In the first column, again, we're going to create the possible outcomes. And you've got 3 different computers that are checked from 10 in the department, okay? Which means that you could get 0 computers that have illegal software, 1, 2, or 3. Okay. Next, we go to the hypergeometric formula, hypergeometric.dist. I'm going to pull up the window here, and we can see it's got a lot of information that we need to put in. First thing says, what is the sample, that is the number of successes in the sample? Well, that's going to be our first column, because that's what we're defining, right? The number of successes in the sample. The number in the sample, this is the size of it, and we know that we selected 3 computers. The population is the number of successes in the population. It should say population success. And it says here 4 of the 10 computers have illegal software, so we're going to put 4 there. The number in the population is 10. Okay? And we don't want cumulative. Click on OK. And then again, we will round to the 10th. Drag this down, and voila, we have a probability distribution for the hypergeometric. Next, we can create the graph. Okay, for this, I'll make it a little bit bigger. Same process, scroll over our data, insert columns, get rid of the unnecessary columns. And again, we have a problem here with the 1. So we're going to select our data, edit it, edit the horizontal axis, and we get our 0. And there we go. So there's our graph. Now let's go on to the next one. It says, your company wishes to purchase 4 pickup trucks from a local car dealer. The dealer has 10 trucks. 3 are lemons and 7 are good. You randomly select 4 trucks. Use Excel to create a probability distribution table and graph for getting a lemon. So to do this, let's pull up our Excel here. And we're going to populate our possible successes. The dealer has 10 trucks, 3 are lemons, and 7 are good. You randomly select 4. So we could get 0, 1, 2, 3, 4, 4. Use the distribution equals hypergeometric. And pull up our box here. Now, what is the number of successes in the sample? And well, that's what we're putting in our column A. What is the number in the sample? We selected 4 trucks. What is the number of successes in the population? Well, 3 of the 10 trucks are lemons. What is the number in the population? There's 10. And we don't want cumulative. So we click 0. Again, round it. Drag it down, and we have it done. I'm not going to do the graph here because by now you know how to do that. The last one says, suppose that 30% of all students apply for admissions to U.S. graduate schools and are accepted for admittance. 10 students attend a special seminar on how best to apply. Let the number of students who are admitted from this group be the random variable. Identify the appropriate discrete probability distribution to use. So it could be the binomial, the Poisson, or the hypergeometric. But notice it says 30% of all students who apply for admission to U.S. graduate schools are accepted. That means 70% are not. This is a success-failure scenario. That rules out the Poisson. Then we say, is it the binomial or the hypergeometric? Well, 10 students attend a special seminar on how best to apply. That's 10 students, our sample, out of all students who apply for admission to U.S. graduate schools. That's clearly a large population that we're pulling our sample from. So that rules out the hypergeometric. Therefore, this is a binomial distribution. Let's do the computations. Okay? And again, we'll just use the same procedure. In the first column, we'll put the possible successes, our x values. We could have 0, 1, 2, 3, all the way to 10 possible successes. So we'll drag this down. Okay. And then binomial, select this, fill in our data. Right? The first number of successes would be our column, first column, and then trials, we know there's 10. And then probability of success is 30.3. And then cumulative, we don't want that. Okay. And now we can drag that down. We can change it to percent. Okay. We can round it to the 10th place. And there we go. We can also create a graph. Go up here, go to Insert, Charts, Column, Graph. Right? Same process. Right? Once you get the hang of this, it's quite simple. Okay? Edit our range here. And there we go. we are done.